All right, so the first part of our review talks about comparing fractions using the strategies that we talked about in class, comparing to half, same numerator, same denominator, positive versus negative, or negative versus negative. Our first comparison is a negative versus negative, and the one that is more negative is actually smaller than the one that is closer to 0. So I always like to think about it as everything's opposite in negative land. We've talked about that in class before, that negative numbers are opposite positive numbers. So if I think about these numbers as positive fractions, I would think about them as 3/6 and 9/16. This fraction is half, this fraction is more than half. So on the positive side of the number line, 9/16 would be greater than 3/6. On the negative side of the number line, the actually opposite is true. Negative 3/6 is greater than negative 9/16. The next one is a positive versus a negative. Positive is always greater than negative. That's an easy one. This one has the same numerator, so when we're talking about same numerator fractions, you want to think about the size of the piece. If I get 4 pieces of a pizza cut in 9 slices versus 4 slices of a pizza cut in 6 slices, the sixths are going to be larger pieces. So even though I'm getting 4 bigger pieces. So 4/6 is greater than 4/9. The last comparison is both improper, so I'm going to change these to mixed numbers to see if it helps me think about them. I know that 7/10 is the same as 1 whole and 3/7. Sorry, 10/7 is the same as 1 whole and 3/7. And 13/5 is the same as 2 wholes and 3/5. That definitely helps me think about this. This is 2 wholes versus 1 whole. 2 whole and 3/5 is more than 1 whole and 3/7. We're thinking about decimals on a number line. We're looking for decimals that fall in between 64 hundredths and 65 hundredths. If you think about our zoomable number line where we zoomed in on our hundredths, we saw the thousandths that were in between. So I'm going to go ahead and just kind of add an invisible 0 to help me think about some thousandths that could be in between these two numbers. So if I have 640 thousandths and 650 thousandths, there are a lot of numbers that would fall in between. 641 thousandths or 642 thousandths or 643 thousandths or 644 thousandths, and you get the idea, on and on and on up to 650 thousandths. Same thing with our negative decimals. If I'm looking at my tenths place value and I'm zooming in between those two place values, I'm zooming into my hundredths place. So I would need some numbers that fall in between negative 88 tenths, or negative 80 hundredths and negative 90 hundredths. So in between there would be negative 81 hundredths, negative 82 hundredths, negative 83 hundredths, negative 84 hundredths, and on and on. On the back side, we are comparing fractions and mixed numbers and negative numbers, so we have a lot to think about here, and we want to place them in order from least to greatest. So I'm going to start by just putting my 0 in the middle because that's going to help me think about the positive side of my number line and the negative side of my number line. If I focus on my negative number line first, my number that is the most negative, the furthest away from 0, is going to be my smallest number. So looking at these two fractions that I have right now, this is almost negative 1 whole, and this is not. It's not close to negative 1 whole, so it's actually going to be closer to 0. So this is my smallest fraction. It's the most negative. It's the furthest away from 0. So I'm going to do negative 5/6 And then my next negative number is negative 2/5. All right, so now let's think about the positive side of our number line. 7/3, 1 1/4, and 18/10. I want to get these all in the same format, so to help me think about them, 7/3 I know is the same as 2 1/3, 1 1/4, and 18/10 is the same as 1 whole and 8/10. So putting them into mixed numbers helps me think about them. It also helps me see that 2 1/3 is my biggest number, my greatest number that I have on my number line, or out of my set. Now it's just down to 2. Which one is greater, 1 1/4 or 1 8/10? I know that 1 8/10 is bigger because it's closer to 2 wholes than 1 1/4. 8/10 is greater than 1/4, so this is my next fraction in the list, and that's my remaining fraction. So putting them in order from least to greatest, just using those common sense strategies that we've already practiced from the previous page should help us out. Using ratio, the ratio of boys to girls in Mr. Jones' class is 3 to 1. For every 3 boys, we have 1 girl. If there are 5 girls in the class, how many boys are there? So using that ratio thinking, I'm going to show you how to solve this 2 different ways. I'm going to use a ratio table for both boys and girls. I know that for every 3 boys, we have 1 girl. That means every time we add 3 boys to the group, we have to add 1 girl. The target we're looking for is what if there were 4 girls in the class? So every time we add 3 boys to the class, we have to add 1 girl. So if there's 6 boys in the class, that means there's going to be 2 girls. If we add 3 more boys to the class, we have to add 1 more girl. That means 9 boys and 3 girls. 3 more boys would give us 12 boys, and 1 more girl would give us 4 girls. For every 3 boys, we have to add 1 girl to keep our ratio equivalent. If you want to think about it as a multiplicative step, I would think about how many times bigger are the girls. So we talked, hold on, let me get this so you can see it. We know that we started with our boy and girl ratio. For every 3 boys, there was 1 girl. And they told us, what if there was 5 girls in the class? I would say that the relationship between the number of girls just increased by a factor of 5. So the boys would also increase by a factor of 5. And there would be 15 boys in the class. All right, putting these decimals in order from least to greatest and then placing them on the number line. So when we compared decimals in class, we compared them by place value. That was one of our strategies. So we wanted to make sure that the place value of our decimals was easily compared. So stacking them up one on top of the other was one of the strategies that we saw on our activity. So I'm going to do that same thing right now. It looks like the largest place value we have is thousandths, tenths, hundreds, thousandths. So I want to make my decimal in the form of thousandths. And I'm just going to stack them right here under this one. So this next one, if I add that invisible 0, that is 190 thousandths. This one is 900 thousandths. And then this last one, 0.09, and then so that's 90 thousandths. So from least to greatest, I'm going to go for the greatest one first. 900 thousandths, that's going to be my biggest one, 900 thousandths. 900 thousandths. And then my next number is going to be 190 thousandths. This is between 90 thousandths and 19 thousandths. So 90 thousandths is my next one. And last but not least, 19 thousandths is going to be my last or smallest. All right, so now I have them in order from least to greatest. And now they want us to put them on this ruler and figure out where each one of these numbers would fall. Unfortunately, it's marked off in tenths, and then in between the tenths I can see 100ths, but I don't see 1,000ths. So I'm going to again change these decimals to match my model. Most cases, all I can do is just get rid of the 0 on the end and think about them in the form of hundredths instead of thousandths, because my ruler's not marked in thousandths. So if I have 90 thousandths, that's the same as 9/10ths. So I think this fraction or this decimal goes right there at the 9/10ths mark. This is 19 100ths. So if I count off 10 100ths, 19 100ths is going to be right here, right before 2/10ths. 9 100ths is going to be, if I count off 9 little marks, that's 9 100ths. And this is 1 100th and 9 thousandths. So that's almost 2 100ths. If we rounded this up, this would be 0.020, which is almost 2 100ths, and that's way down here. All right, last but not least, we talked about fractions as division problems. Gunning Bedford ordered 135 boxes of crayons. They wanted to share them equally among 12 sixth grade teachers. How many boxes of markers will each teacher get? Write your answer as a fraction and a decimal. This is where your fraction and decimal benchmark sheet is going to come in handy for you. So if we're writing the fraction as a division problem, we are going to take those 135 boxes and share them with 12 teachers, and that technically is a fraction. But if I want to make a little bit more sense out of this problem, I want to know how many whole boxes and how many parts of boxes will I get. I want to know how many times does 12 go into 135. I know 12 times 12 is 144, and that's too much, but 12 times 11 is 132 with a remainder of 2, okay? So that means each teacher can get 11 boxes with the remainder of 2/12. I know that 2/12 is also equivalent to 11 1/6. And I can check my fraction and decimal sheet for 1/6. If I go ahead and pull that out right now and check that out, the decimal form for 1/6 is 11.1666, or if you want to round it, 11.167. Sorry, scoot that up so you can see. So we're going to be looking at our fraction with remainder to find the decimal version. And guys are clearly already here. If you're watching the video, we're checking our work at bit.ly/CBPquiz2.